The solar system is made up of gravitationally connected components that circle the Sun. 4.6 billion years ago, a vast interstellar molecular cloud broke apart due to gravity. The bulk of the system's mass, 99.86%, is found in the Sun, with the majority of the remaining group found on Jupiter. The terrestrial planets of the inner system, Mercury, Venus, Earth, and Mars, are primarily composed of metal and rock. Compared to the terrestrial planets, the four enormous planets of the outermost system are much larger and more prominent. The primary constituents of Jupiter and Saturn, which are gas giants, are hydrogen and helium. Uranus and Neptune, on the other hand, are ice giants, mostly made up of volatile materials like water, ammonia, and methane. The Latin word sol, which meaning about the Sun, is where the word solar originates. The main gravitational force in the solar system is the Sun, around which the planetary system develops slowly and steadily by completing solitary orbits subject to gravitational constraints. The ecliptic, or plane of Earth's orbit, is in close proximity to the planets and other big objects that are in transit around the Sun. Comets and other smaller ice particles often orbit at substantially higher inclinations than this plane. Natural satellites called moons circle a number of the solar system's planets, which are known as their secondary systems. Numerous enormous natural satellites orbit in synchrony, constantly facing their parent. Narrow bands of microscopic particles known as planetary rings orbit the four massive planets simultaneously. As a result of the solar system's formation, planets and the majority of celestial objects orbit the Sun in the same direction. In other words, as viewed from above the North Pole of the Earth, clockwise. Of course, there are certain exceptions, like Halley's Comet. While Triton, the largest moon of Neptune, revolves in a retrograde direction, the majority of the planet's massive moons orbit in a prograde direction, mimicking the planetary rotation. With the exception of Venus, which rotates in the opposite direction, most large objects move prograde around their axes in relation to their orbits. While the orbits of most asteroids, comets, and objects in the Kuiper Belt are very eccentric, planetary orbits are almost circular. The gravitational pull of many bodies on one another is not taken into consideration by Kuiper's laws. Rather, they solely explain the gravitational attraction of the Sun to a planet in orbit. The overall composition of the solar system known to science consists of the Sun, four smaller inner planets surrounded by a belt of largely rocky asteroids, and four giant planets encompassed by the Kuiper Belt of mostly frozen objects. This structure can be randomly divided into several parts by astronomers. The four terrestrial planets and the asteroid belt make up the inner solar system, whereas the four gigantic planets and asteroids make up the outer solar system. The solar system's outermost regions have been understood to consist of objects beyond Neptune since the discovery of the Kuiper Belt. The Sun is the solar system's main component. It is gravitationally dominated by this low-mass star, which makes up 99.86% of the system's known mass. The remaining group was made up 99% of the big planets, the four largest rotating bodies around the Sun, of which more than 90% was made up of Jupiter and Saturn. Less than 0.002% of the solar system's mass is made up of the remaining objects, which include the four terrestrial planets, exoplanets, satellites, asteroids, and comets. 4.6 billion years ago, a region inside a huge molecular cloud collapsed due to gravity, creating the solar system. More than one star was born from this initial cloud, which were probably many light years across. As is typical of molecular clouds, the bulk of this cloud was hydrogen, with traces of heavier elements like helium from earlier star generations. It had to rotate faster than the pre-solar nebula, or region that would eventually give rise to the solar system, according to the conservation of compressed angular momentum. The planets were created by the gas and dust from this disk accreting, pulling on one another and merging to form ever larger masses due to gravity. The original solar system may have had hundreds of protoplanets, but they merged, were destroyed, or were driven out, leaving the planets, dwarf planets, and smaller bodies. Only metals and silicates could exist in solid form in the hot inner solar system close to the Sun due to their higher boiling temperatures. In the end, they would give rise to Mercury, Venus, Earth, and Mars, the terrestrial planets. Rocky planets were unable to become big because metallic elements were so minute in the solar nebula. Beyond the freezing point of water, the temperature differential between Mars and Jupiter's orbits at which volatile ice compounds freeze, Jupiter, Saturn, Uranus, and Neptune arose. Because the ices on these planets were more frequent than the metals and silicates that formed the terrestrial inner planets, these planets were able to grow to tremendous sizes and retain massive atmospheres of hydrogen and helium, the lightest and most numerous elements. The Oort cloud, Kuiper Belt, and Asteroid Belt collected debris that did not become planets. The Sun is the solar system's star and by far its largest element. Its huge mass, 332,900 Earth masses, produces core temperatures and densities high enough to sustain the nuclear fusion of hydrogen into helium, accounting for 99.86% of all groups in the solar system. It produces enormous amounts of energy, which are mostly released into space as electromagnetic radiation peaking as visible light. The Sun's basic process of converting hydrogen to helium makes it a main sequence star. The star's effective temperature determines its categorization as a G2 type main sequence star. The Sun's temperature is midway between that of the coldest and most desired stars, and hotter main sequence stars are brighter. Over 75% of the stars in the Milky Way are red dwarfs, which are harder and darker than Sun-like stars. Stars that are hotter and more luminous than the Sun are rare. The asteroid belt and the rocky planets are parts of the inner solar system. The inner solar system's objects, which are mostly silicates and metals, are located quite close to the Sun. In fact, the region's total radius is less than that of the orbits of Jupiter and Saturn. Located around 750 million kilometers, 460 million miles, from the Sun, this region is also close to the frost line. The four terrestrials, or inner, planets lack ring systems, have few or no moons, and are composed of solid, rocky material. Their cores are mostly composed of metals like iron and nickel, as well as refractory elements like silicates that make up their crusts and mantles. In addition to having massive atmospheres that sustain weather, Venus, Earth, and Mars also have tectonic surface features including volcanoes and rift valleys, as well as impact craters. Mercury and Venus are examples of inferior planets, which are planets that are closer to the Sun than Earth. However, they should not be confused with inner planets. Nearest neighbor of the Sun, is Mercury, 60 million kilometers, 37 million miles. With 0.055 Earth masses, Mercury is the smallest planet in the solar system and lacks any natural satellites. The most notable geological features include lobed ridges, or rhoos, which were probably produced during an early period of contraction on the planet, impact craters or basins with blankets of ejectae, and the remains of early volcanism, including magma flows. Venus is comparable in size to Earth, 0.815 m Earth, with a thick silicate mantle around an iron core, a sizable atmosphere, and signs of internal geological activity. Venus is located 100 million kilometers, 65 million miles, from the Sun. Its atmosphere is 90 times denser than Earth's, and it is drier. Venus does not have any natural satellites. With surface temperatures approaching 400 degrees Celsius (752 degrees Fahrenheit), it is the hottest planet due to the quantity of greenhouse gases in the atmosphere. One 150 million kilometers, 93 million miles, from the Sun is Earth, the largest and densest of the inner planets, the only one thought to have active geological activity, and the only place where life is known to exist. Of all the terrestrial planets, it has the only liquid hydrosphere, and evidence of plate tectonics has been found. Since the emergence of life, Earth's atmosphere has changed significantly from that of the other planets, including 21% more free oxygen. By shielding the planet's surface from cosmic and solar radiation, the planetary magnetosphere prevents atmospheric stripping and maintains habitability. It has only one natural satellite, the Moon, which is the only large satellite of a terrestrial planet in the solar system. At 220 million kilometers, 140 million miles, from the Sun, Mars is smaller than both Earth and Venus, 0.107 m Earth. Its primary atmosphere is composed of carbon dioxide, and its surface pressure is 6.1 milliards, 0.088 psi, 0.18 in Hg, or around 0.6% of Earth's pressure, which is sufficient to support meteorological events. With rift valleys like Valles Marineris and volcanoes like Olympus Mons dotting the landscape, it is possible that geological activity occurred as recently as 2 million years ago. The iron oxide, rust, in the soil is what gives it its red color. Demos and photos, two of Mars's natural satellites, are thought to have been ejected debris from an early, major impact on the planet or imprisoned asteroids. With the exception of Ceres, asteroids are small objects found in the solar system that are mostly made of refractory rocky and metallic components, along with some ice. Their sizes range from few meters to several hundred kilometers. The terms meteorite impacts and micrometeoroids, grain-sized, are used to describe asteroids with a diameter of less than 1 meter. However, the exact differences between the two classifications have long been debated. As of 2017, the IAU classified asteroids as dust if they are less than 30 micrometers and asteroids between 30 and 1 meter in size as micrometeoroids. At a distance of 2.3 to 340 to 490 million kilometers, 210 to 310 million miles, from the Sun, the asteroid belt revolves around Mars and Jupiter. It is thought to be remnants of the formation of the solar system that were prevented from merging by Jupiter's gravitational pull. tens of thousands, if not millions, of asteroids larger than 1 kilometer in diameter can be found in the asteroid belt. In spite of this, it is improbable that the asteroid belt's total mass is larger than 1,000th of Earth's. There are hardly many people living in the asteroid belt, yet spacecraft often pass through it unharmed. The outer region of the solar system is home to the large planets and their huge moons, as well as centaurs and a number of comets with short orbital periods. The outer solar system's solid objects include a higher proportion of volatile elements like water, ammonia, and methane than the inner solar systems because of their greater distance from the Sun, which allows these compounds to remain solid at lower temperatures. "99% of the mass that orbits the Sun is made up of the 4 outer planets, sometimes referred to as big planets or Jovian planets. The names gas giants refers to Jupiter and Saturn, which have masses more than 400 times that of Earth and are mostly made of the gases hydrogen and helium. Both Uranus and Neptune are mostly composed of ice and are far less massive than 20 Earth masses, m-Earth. These are the reasons why some astronomers think they belong in the category of ice giants. While the rings of all 4 big planets are visible from Earth, only Saturn's ring system is. The outer planets and Mars are included in the category of planets outside of Earth's orbit when the term ideal world is used. It is mostly composed of helium and hydrogen. The Great Red Spot and other semi-permanent atmospheric phenomena like cloud bands are created by Jupiter's extreme interior heat. The planet is the most conspicuous object in the solar system in certain respects due to its 4.2 to 14 Gauss magnetosphere, which stretches over 22 to 29 million kilometers. There are 80 known satellites of Jupiter. Since the 4 largest, Ganymede, Callisto, Io, and Europa, have characteristics with terrestrial planets like volcanism and internal heating, they are collectively referred to as the Galilean moons. The atmosphere and magnetosphere of Saturn, which is 1.42 billion kilometers, 880 million miles, from the Sun, are similar to those of Jupiter in many ways. In the solar system, only Saturn has a density lower than that of water. Small pieces of ice and rock make up Saturn's rings. With an axial tilt of more than 90 degrees toward the ecliptic, it is the only planet to orbit the Sun on all of its sides. The planet undergoes notable seasonal variations due to the orientation of its poles towards and away from the Sun, and its core is far more relaxed in comparison to the other main planets. It releases a small amount of heat into space. Neptune is more massive, 17 m-Earth, and hence denser than Uranus, although being considerably smaller, 4.50 billion kilometers, 2.80 billion miles, from the Sun. Its interior temperature is higher than that of Uranus, but lower than that of Jupiter or Saturn. There are 14 known satellites of Neptune. Numerous small planets known as Neptune Trojans orbit Neptune, either leading or trailing it by approximately 1/6 of its circumference at locations called Lagrange points. Similar to the asteroid belt, the Kuiper Belt is a massive ring of debris composed mostly of ice-based objects. Its distance from the Sun ranges from 30 to 4.5 to 7.5 billion kilometers, 2.8 to 4.6 billion miles. It is mostly composed of small bodies from the solar system, with dwarf planets probably making up the large handful. Pluto is the well-studied planet in the Kuiper Belt, with an average orbital distance from the Sun of 5.8 billion kilometers, 3.6 billion miles. When it was discovered in 1930, it was believed to be the eighth planet. However, in 2006, a formal definition of a planet was introduced, changing this belief. Due to the 2:3 resonances between Pluto and Neptune, Pluto orbits the Sun twice for every 3 Neptunian orbits. The largest moon of Pluto, Charon, is frequently thought of as being in a binary system with Pluto because the two planets appear to orbit each other around a gravitational barycenter above their surfaces. For much smaller moons, Styx, Nix, Kerberos, and Hydra orbit Pluto. Subscribe to Junior Library's channel for more engaging content designed to inspire and educate young minds.